Hello, my name is Kevin, and today I'm going to show you what a hyperbola looks like. So a hyperbola is a curve where the distance of any point from a fixed point, also called the focus, and a fixed line, which is known as the directrix, are always in the same ratio. So in the Conic section, we cut two cones like this, just straight down. We have an hyperbola like that. So the hyperbola's equation can be shown in two different forms. The first form is x minus h over a squared minus y minus k over b squared equals 1. And what that looks like on a graph is the curves are left and right of each other. So it will look like this. And for the second, we have y minus h squared over a squared and x minus k squared over b squared equals 1. And the curves are above and below the x-axis. Okay, so graphing, as an example, so we have the equation x squared over 16 minus y squared over 9 equals 1. What I mentioned earlier was on the formula there was an h and k, but since there's no h and k, the h and k are known as the center of the hyperbola. So since there's no h and k, the center would be right here at the origin at 0, 0. So we found our center of the hyperbola. Now for 69, whatever's below the leading variable, so it's x and it's 16. So on the formula, we had x squared over a squared, right? So a squared is equal to 16, square that, and a equals to 4. So we take that value 4, we go from the origin, and then we go left and right 4. So 1, 2, 3, 4, and 1, 2, 3, 4. The point that we stopped at when we use 4, that's called the vertex of the hyperbola. So we have a center at 0, 0, and our vertex of the hyperbola, it's at 1, 2, 3, 4. We have a vertex at 4, 0, and we have a vertex at 1, 2, 3, 4 at negative 4, 0. Okay. So b squared equals 9, square that, so b equals 3. So we go from the vertex, and then we go up 3, and down 3. To the other vertex, we go up 3, and then we go 1, 2, 3, down 3. And we want to create like a little perforated rectangle right here. And what this is it's going to be your asymptote. So the asymptote is going to be b over ax and negative b over ax. So 1, 2, 3, 1, 2, 4. 1, 2, 3, 1, 2, 3, 4, go back to the origin. Actually, sometimes should be dotted. So it's like that. That's negative. That's negative b over x. So just go like that. And b over ax. So 1, 2, 3, and then up 3, and then right 4. So 1, 2, 3, 4. And since the curve shouldn't touch the asymptote, so draw the curve, it shouldn't touch the asymptote. It should be very close to it. So that's one part, that's one curve. And this is another curve. And that's how you graph the parabola. And to find the focus is c squared equals b squared plus a squared. So our b squared is 9. c squared. So c squared equals to 25. Oops. Square both of them, and c equals 5. Now we take that value, and we start at the origin. We start at our center of the hyperbola, and we go, depending on where the x and y value is, that's where we go. That's the direction. That's how many units you get to move, according to which variable is in front. So if it's x, you move 5 to the left and 5 to the right. If y is in front in the equation, then you go up 5 and down 5. Since x is in front, so you move 5 to the right and 5 to the left. So 1, 2, 3, 4, 5. This is our focus. And then 1, 2, 3, 4, 5. And that's our other focus. So right here, these are focus and focus. And our focus is at 5, 0 and negative 5, 0. And those are the critical points and how a hyperbola should look like. Okay.
Ellipses are defined as a curved line forming a closed loop, where the sum of the distance from the 2 points, the foci, to every point on the line is a constant. Sometimes these ellipses can be described as a stretched out circle or an oval. For example, if we have this toilet paper shaped as a circle, when we push in, it becomes an oval. Now that we know a little bit more about ellipses, let's go ahead and try to graph one. So we have this equation, x squared over a squared plus y squared over b squared equals to 1. For this one, x and y represent the x and y coordinates for the center of the ellipse, which is going to be a 0, 0. So once we go ahead and graph that, we have our center point right here, 0, 0. For our graph, we're also going to take the points A and B, where A is the horizontal semi-axis and B is the vertical semi-axis. Let's go ahead and try to use this example to graph an ellipsis here. Since we know that A is 3, we can go ahead and graph this on the x-axis. So we go 3 to each side. We're going to have point A here, which is going to be 3, 0, and another point over here, negative 3, 0. And for B, we have 2, where we're going to go on the y axis, 2 up and 2 down. And we have points 0, 2 and 0, negative 2. Now that we have these points, we can go ahead and graph our ellipse as best as we can, making the oval shape. Okay, so now that we have graphed our ellipse, we can go ahead and find our foci, which is the 2 focus points of the ellipse. For this, we can use the equation c equals to a squared, the square root of a squared minus b squared. For this, we can substitute the number that was given as a squared and b squared. In this case, it's going to be 9 minus 4. Once we work this out, we get the square root of 5, which is going to be equals to approximately 2.24. Now that we have our c, which is our foci, we can go ahead and graph that in the equation. The foci, we can find it in our major axis, which is the longest axis in our ellipse. In this case, it's going to be on the x-axis. So we go ahead and put graph 2.24, which is going to be here. And this is one of our foci. And the other one is going to be on the other side of 0. And there we go. We have our foci which are the focus points. X minus h squared over a squared plus y minus k squared over b squared equals to 1. For this one, we notice that this is different from the general equation. We have h and k, which in this case they represent the x and y coordinates for the center of our ellipse. Knowing this, we can go ahead and try to work with this example. We have h to be our 1 and our k is 2. For this, we can go ahead and graph our point for the center of our ellipse. So it's going to be 1, 2, and here is our center. After this, we can go ahead and follow the same procedures we did before, using A and B to graph our ellipse. So for A here we have 3, and for B we have 2. A we go, since it's for the x-axis, we go 3 to the left and 3 to the right. So we have negative 2, 1, and 4, 1. B is up and down, since it's for our y coordinate. We go 2 up, we have 1, 4, and 2 down, we have 1, 1. So after this, we can go ahead and graph our ellipse. For our foci, it will be the same, since it's going to be on our major axis. So we can go ahead and do the same. C equals to the square root of a squared plus b squared minus b squared. And we can find the foci, which is going to be again at square root of 5, which is going to be approximately 2.4 and 2.4 on the same, the longest distance of the major axis, which is the major axis, and then we have graphed our ellipse.